Okay, today we're going to be using bearings, so I'm going to review that with you. We're going to be using both kinds, the true bearings and also the kind where you say like 30 or north, 30 degrees west, that kind of bearing. All right, you got to know both of those. You got to be able to write trig equations, and you got to realize that this isn't a right triangle, and therefore it won't work to use trig. You know, you can do that, but it's only on right triangles. Okay, so let's do a little bit of review first. So let's start by just adding in a blank page. And let's see if you can do a plain old-fashioned with a right triangle. Because even though the triangles for today aren't right triangles, there are right triangles around the outside of them. So you're still going to boil down to using right triangles. All right. So I'd like you to assume for a moment that this is 26 degrees. Why not 30? Because they're not always going to be like that, and I warned you about that. So we have a way of doing this. If this side here is 8, I'd like you to figure out how long that side is. Let's give it a variable name. Let's call it h for hypotenuse. Would you please use trig and find h? I'm going to pause for a second. Will you try that and get people into groups? All right. If you haven't figured this out yet, the 30, 60, 90 is close, but it's not going to work. So you can't do the helper triangle thing. You can do sine of 26 is equal to 8 over h. And then you can, well, I personally multiply both sides by h and then clear the, so the fraction is cleared. And if I do that, h isn't alone yet, so I've got to then divide both sides by sine 26. And you can use a calculator. Give me a decimal. It's okay to leave a decimal answer on this. If you haven't already, get it, because I'm going to use Dice of Destiny to get somebody to give me that answer. Yes, ma'am. Good question. If a test question were to ask, give an exact answer, and they're usually like really clear, like at the end of the question, give an exact answer. As soon as you've rounded something, it's not exact. So if we wanted an exact answer here, the answer would be 8 over sine of 26. And if we want a decimal answer, they usually say what to round to. Obviously, you're going to have to round it, and it's not exact anymore. All right. So here is row 6, last person. That's rare 6-6 combo. Boom, boom. Yes. What do you got? How about this? I just need the decimal at the very end. Hopefully you divide it here. H is equal to, maybe you haven't finished that yet. Anybody verify 18.2? All right, a bunch of people are nodding their heads. If you didn't already do this, it should have been 8 divided by sine 26. And if your calculator is in radians, it won't be the right answer, of course. One last time, what'd you guys get? 18.25, so it all probably depends on where you're round, but raise your hand if you had an answer that was like that. Okay, good. All right, so there's just plain old-fashioned trig with a right triangle. So how do you do trig when there isn't a right triangle? It usually revolves around bearings. So here's a situation. This is called a compass rose, north, south, east, south. No, south, east, west. Then generally place this in the lower left. And we're going to be moving this away. Now, there's two ways I could say that. I could say that that's like 85 degrees true. Or do you get, I could write it a different way of north. And it's kind of like you were heading north, except you're going to swing 85 towards the, I always get my east and west confused. There we go, east. North 35 degrees east. Do you get that that would be the same exact spot? Okay. All right. So now, how far have I gone in that direction? I'm going to tell you a number. Let's say that this is a ship out in the ocean, and it sailed for 3 miles in that direction. Now, if I gave you an easy one, it would just go straight south from here. And even those are hard to do unless you're good at doing the compass rose thing and everything. All right. So I guess I'm going to give you one. It's going to be super easy, but I'd like to have you tell me if they were to only be able to head north, south, east, or west, as in their compass is like stuck on their ship. They can't do like in betweens. Obviously, they're going to head south for a while, and then they're going to head back west for a while to get back home. This was home. My question is, how far south should they go? And how far west should they go? You have everything you need because you have a right triangle and you have a side and angles in it. So take a moment to draw your right triangle, label all of its sides and all of its angles, and you'll be able to answer how far south should they go and then how far west should they go to get home. That's that and that to get home. Pausing while you work on that. So these are tough. They're tough for a lot of reasons, but one is that a lot of times people don't draw the little compass rose in every spot where you start or stop. Okay? Another reason people have trouble with these is they have trouble because they don't label some of the angles. If you just don't label one of your angles, that might be the one that really was important. So try to label all your angles and all your sides of your triangle. All right, pause for a second. You work this out a little further. All right, so when I said it was 85 true, that meant that this angle right here was 85. And then that should tell you what the remaining angle is that's left to get to 90. Of course, it must be what? 5. So this angle of my brand spanking new, I'm going to like draw them off to the side here. My new triangle that I've just made has a side of 3 and an angle of 5. And it's a right triangle too. Make sense? Okay. So then, RS, tell me some more stuff that you figured out. Angles, sides, tell me what you do. Sine of, and I'm going to call this y, and I'm going to call this x. You could have called them anything, but I'm going to say sine of 5 is equal to y over 3. Awesome. So then if you multiply both sides by 3, you got y, or whatever you called that, was 3 times the sine of 5. Raise your hand if you had that one right. Awesome. Okay. How do you get the x? Well, I can do cosine for that. Cosine of 5 is x over 3, adjacent over hypotenuse, and so 3 times the cosine of 5. All right. Now, this one was pretty easy because it was a right triangle. Now, I did help you a lot to set it up, though, so I'm going to give you one more like this where I don't help you set it up, and you have to draw the whole thing perfectly, label all the sides, all the angles, okay? And then we move up to the next level, which is where it's not a right triangle, so you have to make right triangles out of it. Okay, so here we go. Your boat starting in the ocean, and you drift because your boat just sank right there, and you're drifting. And you're drifting on a course of 170 degrees true bearings. 170. You drift for 3 miles. The question is, how far south are you of where the boat sank? I didn't ask you for like a diagonal distance, it's just the south part. So if, for instance, you drew something like this, all I asked is how far south you were, which would be like that green side there. Okay? I didn't draw it perfect. I want you to figure out this answer. You drifted for 3 miles. How far south are you of your original spot? Now, I gave you tips. Please use all of them. Like, draw a compass rose at every corner of your right triangle. Number 2, label all the sides and all the angles. Every angle you can see, except 90s. Don't bother to label those. They're obvious. You can tell they're 90s. All right, I'm going to pause for a second. One last time, what was the angle, the true bearing? 100 and what? 170 what? True? Thank you. All right. So again, I did not draw that right on purpose. You draw it in the right place and figure out just how far south are you of your original. I'll pause. So you're right. It goes in this direction. That was your 170. I would have thought of it maybe as like 180, except not quite. All right, 180 be like all the way to here, but not quite. So then, remember my advice about labeling all the sides and all the angles? If that was 170, this part's 90, then what's that part? I know some of you are thinking, well, do I even need? Yeah, you should label all the angles that you can see, except unless they're 90s. Okay, so if that's 90, how much more to make it a total of 170? Isn't that 80 degrees right there? Okay, all right. And then, how about this angle right here? Should you label that? Yeah, you should. You should label all the angles you can. That's 10. Okay, and then what's another thing that I said? Always put a what at the end where you stop? Compass rose. All right, some compass rose right there. If you end up not taking these pieces of advice, I'm telling you, these are going to kick your butt. They're hard, and you're going to be tested on. Okay, and the test, by the way, isn't going to be Monday test. That'd be just terribly cruel. But if everything had been on track, like we hadn't had the weird thing, we would have today the new stuff, and then tomorrow a review day, and then the next day be a test. Okay, so you were scheduled to theoretically test. It could have had you test on Friday had we not had that week. All right, so that doesn't mean the test is Monday. And it's probably Tuesday or Wednesday. I'll tell you for sure on Monday. But it's coming quick. And we can't afford to just like extend it even further because we've already just lost 3 days. So, all right. We're not going to go faster because of the 3-day thing. We can actually just stay on track. But I can't afford to slow down, that's for sure. All right. So what's that advice about labeling? I should label all the angles unless they're 90s. Like obviously that's a 90, 90, 90. Don't need to label those. But these other ones, I can label those? Yes, you can. All right, let me just for a second remind you about if you have two parallel lines and a transversal, do you remember this thing where if I knew this angle was, let's say, 110 or something degrees, that one of the other two angles over on the other side is 110? Do you remember that? That's important to remember. Which of these two looks like 110, angle 1 or angle 2? Angle 2 must be 110. Okay. My point is, you have to be able to make that transfer. It's going to happen a lot today where you're going to have this cluster of angles, and then you'll have a transversal, and you'll have another cluster of angles, and you have to be able to jump like from here to here. Well, where's that over here? Well, these are all 90, so we're not talking about those. I'm going to fill this in for you and see if you catch this. So if I had a pink line that's running straight north-south here, I got all tilty. Hold on a second. I'm going to try that again. There. And I have this straight line running straight through there. Do you get that the red line is like a transversal? Okay. And then this little angle here transfers over to there. Do you see why that's important? Because if this is 10, then that tells me this angle. How much is this angle? That must be 80. All right. And now, if you drew in the triangle you were supposed to, you should have drawn it right here. And do we have one of those sides? Yeah, I told you you drifted for 3 miles, so that side's 3. And I'm going to make this cleaner. Whenever it gets too messy, go off to the side, draw a separate one. This is 3. This is 10 degrees. This is 80. It's a 90-degree angle because it's a right angle. And then I wanted to know this distance, which I'm going to call A. That's how far south were you of your original starting position. And hopefully you solved for A and you got, let's see, I'm going to use the 80. You could have used the 10, but I'm going to use the 80. I'm going to use sine of 80 is equal to A over 3. And that way I can just times both sides by 3. And cancels. A is equal to 3 times sine of 80. And you might have done it with the 10. If you did it with the 10, it would have been cosine of 10 is adjacent to hypotenuse is a over 3. And do you remember that deal where sine of 80 is the same as cosine of 10? Does that ring a bell? You remember that? Okay. Either one of those would work. What'd you get for final answer? RS? What was A? If you haven't done it yet, use calculator, do it quick. Or do you have it and I couldn't hear it? Okay. 2.95, can anybody verify that? All right, cool. Basically, it's really close to the 3 miles in the first place. Why? Because we were mostly drifting south when we drifted 3 miles. We were drifting south, but just a slight bit off of south. That's why it isn't 3. All right. So that was a right triangle. One more time. What's today about? Not right triangles. So here's a typical scenario today. I'm not going to give you, don't copy this one down because we'll do real angles in a second. But do you get something like that where it's not a right triangle, has right triangles all around it? Like, for example, can you see this right triangle that's around the outside of it? Okay, and there's a right triangle over here. You get what I'm saying? All right, and where's the last one? This one's a little harder to see. But if I put a compass rose at each spot that I'm at, you might be able to see, yeah, I gotta put this up a little bit, where that last right triangle is. And I'm gonna, it's even hard for me to see. Hold on a second here. Oh, I wish I would have made that taller. And this is messing with my head because that, okay, I didn't make my plus sign right, so I gotta make that sharper and crisper. There. There we go. Okay, so my last right triangle I'll make in green here. It's a very narrow little wedge of a right triangle, but it is a right triangle. There we go. So there's 3 right triangles around every non-right triangle. Okay, there's also another way to do it, but I'm telling you from my experience, it's a lot of times harder. And that is, oops, I'm wrong. You could drop a right angle right there and make 2 right triangles out of it. But you know what makes it hard? You won't know how long this and this are. Do you get what I'm saying? Okay, so it would be, it is a way, but I'm going to suggest you not use that. From my experience, these are hard enough as it is. I'm not going to want you to have too many different ways floating around in your head to do them. If you make 3 right triangles around the outside, 2 of the 3 right triangles you have, you will know a side on them and the angles for them. Those are the ones you want to use. If you have a right triangle where you don't have any sides, that's not the right one to use. There's the other ones, okay? All right, so with all that being said, let's do the Scrappy the dog problem. It's right here. And this is going to get messy. So my best advice for you is blow it up to be as big as you can. Like zoom in on that puppy so that you can make it as big as possible. I can't do that with a smartboard, but you can with your iPad kind of zooming in, right? Because if it's going to get messy, the bigger the better at least, okay? All right. Do you get that from the directions here, you have some angles and you have some sides? In case it's not clear where Scrappy's running, his first trip is down here. He heads down this way. Then he goes back this way. And now he's right here. And you have to go get him. So you're this blue dotted line and you're going to go get the dog. And the question is, what direction should you head? I can say generally it looks about, well, bigger than 90, right? So like, I don't know, 110 or something, but you got to find out exactly what. And you got to know how far that is. All right, so what are the sides that I can label? Well, first of all, it says he runs, help me, this is so small. South 60, east, how long? All right, so then I'm pretty sure, is this south, but 60 east, yeah, this red line right here is. And he goes 2 miles. So we're going to put a 2 right on top of Scrappy there. That length is 2. And right away, label all your angles, right? Did you get that this was south, but we swung 60 east, so that angle's a 60? And we don't know anything about the blue line yet, okay? But at a minimum, we know that this is 90, and this is important. This together, these two angles together have to add up to 30, right? All right. Now label all your sides and all your angles. And then you're going to make right triangles around these things. All right. When he did that down to here, this arrow is messed up. I apologize. I don't know if your arrow has the arrow on that end, but that's where it's supposed to be. He runs this way now. How far? 1. That is a length of 1. You have right triangles all over the place. I'll help by drawing in 1. And you tell me, this right triangle that I just drew in, do I know a side and an angle in it? Awesome, then it's a good one, and I can find all the other sides and all the other angles, and you should. Even if you don't feel like you're going to use it, find them all. Then you'll have another right triangle over here. And people make the mistake of trying to go right for the blue dotted line because you can't get it right away. You have to find a whole bunch of other stuff first. There's my 2 triangles I want you to work on, the green one and the red one. You have angles and you have sides. You might think you don't have this angle, but you do if you read the story of what direction he's heading. It says northwest. Just to clarify, northwest means exactly between north and west. Just like that, which means you've got angles that you know, right? Do you get that this has to be 45? All right. Okay, so you got all the sides and you got all the angles for those 2 triangles. Now the big hoo-ha at the end is, can you figure out this triangle right here? But don't even try until you've figured out the other red one and the green one. All right, I'm going to pause while you work on that for a bit. Okay. Hopefully it wouldn't take too long before you realize that this one is a 1, 2, square root of 3 triangle. Did you figure out that the green one actually worked out that way? All right, and then I said to use decimals. Did anybody figure out that square root of 3 has a decimal? Do it. Take a second, use a calculator, find square root key. You need to learn how to do this because sometimes the test questions ask you for decimals. Round to the decimal, to the nearest whatever. What is the square root of 3? Do you have it? 1.7 what? Thank you. All right. You with me so far? Now, if you didn't notice it was a 1, 2 square root of 3 triangle, I get it, but you should have used trig to do it. You should have been able to go cosine of, and at this point I didn't know what this was, so I'm going to call it like m or something. And I'd say cosine of 60 is equal to m over 2, and then you solve the thing. But you'd end up coming up with 1 for that side. Okay, I got my right triangle, I got a side, and I got angles. Oh, I didn't label this one yet. That might be important. Why? Because it brings me over to this triangle. Here I know this is 45 because it said so, because it said he went northwest. That's why I know that's a 45, and that makes this a 45, 45, 90. You know what I'm saying? All right, now some of you are terrible at geometry. If that's you, this unit is going to be hard because we draw tons of triangles in strange places, and you have to be able to see the right triangles. Not saying that you can't do it, but if you know ahead of time that geometry is your weakest thing, watch out this unit because there's a lot of drawing angles and using things called transversals. And all right, so if this is 30, then there should be another 30 somewhere else up here. Not actually. I'm wrong. That's 30. This is 45. It's this one I was thinking I was going to get. That one right there. Together, this is 30. This, I don't know. And this is 45. Together, they have to make 90, though. Do you get that? That must be 15 right there. How many of you had already figured out that that was 15? Awesome. That's important. It's sometimes just one little angle like that that can set you back. You're like, oh, I can't find this one angle. All right. Now, another way I could have gotten that would have been to say this 60 here goes with this 60 here. Do you see how these, this and this are like, you've got a transversal, and it's like knowing this goes with this, but they're the same. That's geometry. You have to be able to handle that kind of thing. All right, so moving on. If this side is 1 in this right triangle right here, you should have figured out that these other sides are 1 over the square root of 2. But then I told you to use a decimal, and so did you actually divide the 1 over square root of 2 yet? What'd you get? 0.71. Can anybody verify 0.71? A lot of people are nodding, so that's a good sign. Oop, I said 5 by accident. 0.71. Okay. Now, do you remember me saying that this blue triangle was the big kahuna, but not to start with it? Now we've got something. 0.7071, I can buy that, but if you rounded yours, 0.707 would round to 0.71. So we'll give him a break and let him round it to 0.71. Oh, okay. 7. Yeah, okay. So 0.71 is that side. Now, if anybody can see how long this side is, I'm hoping there's a few of you that can see by looking at the symmetry that we have here. By looking at the drawing, you should be able to go, oh, I can see how to get that. What do you think we could do, FK? This distance minus that distance will give you this distance. So it's 1.73 minus the 0.71. Process that. Make sure you understand that, because that's how you get that third side. Now I've got one side in my right triangle. Is that a big deal? Yeah. As soon as you got a side, all you need is a angle. Okay, now other than the right angle. Hopefully everybody can see the right angle. Duh. That's right there. But if we could just have one of the other two angles. Now how can you get those angles? You got to transfer angles around. You got to be able to say, oh, I see. This angle here plus that angle there have to equal 60 or that kind of thing. All right? We're going to pause here until you guys can figure out for me either this angle or that angle and give me a reasoning, a rationale why you know it has to be that. You got it? Already? Okay, wait. Let's give people some time. Okay? Unless you have a question. Good question. If you knew all the sides, you absolutely could figure an angle out that way. Do you see another side that we, like, the dotted line we don't know. That's what we're trying to figure out, right? I like what you're thinking. All right. So she's saying, we already know this side. What if we just knew this side? Then couldn't we figure out from the Pythagorean theorem how long the dotted line is? Yeah, that would work. Or if you knew those two sides, can't you use trig to figure out an angle? Let me just back up for a second. Let's say you had a triangle and you knew one side, which we do, and let's say it was like 0.96 or whatever it is, and then we knew the other side was like 0.62. Couldn't you use trig to figure out how long that angle is? Yeah, and then you'd have an angle. That's another way you could do it. That's really good. All right, just for a second, you and your partner, imagine this was your only problem. You need to have this skill in your tool bag. Use sine, cosine, or tangent, and use inverses to figure out, these are not the right numbers. I know. The real problem, Scrappy problem, we'll do that in a second. Everybody right now, see if you have it in your skill set to find the angle theta on the board right now. Stop for a second, use your calculator, inverse something. Remember, it's not regular sine of those numbers. It's inverse or inverse cosine or inverse tangent. All depends on what you, if you know how to do this. Okay, so I'm sidestepping the problem. I know it's a little annoying, but I need to make sure you know how to do what she just suggested. You guys know how to do this? Okay, in case you've forgotten this, you go, well, what do I have of theta? Do I use sine of theta? Well, I have, from this angle's perspective here, I have opposite and I have not hypotenuse, so I don't use sine. I have opposite and adjacent. Which one uses that? So you go tangent of this angle would be 0.62 over 0.96. And then how do you make that an angle? You go, who knows, inverse tan on both sides. And this cancels this, and theta is that. And you need to be able to do that for your next test. Inverse tan, or could be inverse cosine, or it all depends on which angles we give you, or which sides we give you. All right. I've been picking on you a lot today. Did you already do it? Yep. Inverse tangent of that, what'd you get? Can you verify, did you get 32.86? Maybe the rounding's off a little bit. Yes? Okay, good. Okay, cool. Then you know how to find an angle if I give you two sides. But somebody made a good point. If this is really a right triangle, couldn't you just use the Pythagorean theorem to find that third side? Yeah. A squared plus B squared should equal C squared. Just don't forget that the answer, you have to do the square root of that side, right? Because if we use an example of the 3, 4, 5 triangle, even if you know this is 3 and 4, you go 3 squared and 4 squared, and you don't just add them together. You got to then square root that. It'd be too big because that ends up being 25. And obviously that side isn't 25. Don't forget the square root part. Okay, cool. So back to Scrappy. I love this answer. This side and this side is knowable. How do we find this side? Because we know this and we know that side, which is the same as the other one, 0.71. And we take 1 minus the 0.71, and I think you get 0.29. Is that right? Okay. This side would be 0.29 because you took the bigger side here minus the smaller side here. All right. Whenever it gets this messy, I know we're in a tricky question. We spent a lot of time on it too, right? Okay, so these are not easy questions. What are some keys that I've told you? Number one, every non-right triangle has 3 right triangles around the outside of it. Number two, not all 3 of the triangles are going to work. Only triangles where you have a side and an angle are going to work. Okay, so you do everything you can with those triangles, and then the last triangle, you have to use like just general problem solving. It's not just as simple as it's always going to be inverse tangent, or sometimes you have to use, I know 2 sides of it, and so I can figure out the angle from that. Anyway, your last right triangle gives you your final answer. All right, so somebody by now must have actually subtracted these two and got 1.02, and then somebody must have done something to find the purple side. Did you use, who did Pythagorean and got it that way? Okay, back corner, what did you get, sir, for the Pythagorean weighted? Don't tell me the whole thing, just a final answer. All right, can I round it to 1.07? Did you get 1.07 also? Would it round to that anyway? Okay, 06, 07. We're going to say, don't worry too much about the rounding, because he might have rounded his number slightly different than yours. All right, cool. So then we know we have to travel just over a mile, no, kilometer, sorry, just over a kilometer. And now the last thing is, what's the angle? The question really isn't what's this angle. The question is what's the bearings. It's 90 plus whatever this angle is. You know what I'm saying? So if you want, now that you got all the sides, you could definitely use inverse trig to figure that out. And your answer better be 90 plus whatever you figured out. Okay? So this side right here, this angle, I personally am going to use my original numbers because they're not rounded. And I'll do tangent. I'll say tangent of that angle would be 0.29 over 1.02. And then I'll do inverse tan of this. And that'll tell me that angle. Could somebody tell me what you got? For the little, yeah, this little angle right here. What did you get? 5-0 or 15? Okay, 15 point, what? Let's call it 15.9. Can we agree on that? All right, so if we take that as 15.9, this guy right here, then you add that to the 90, and the direction you need to head is 90 plus the 15, which makes 105.9 degrees is your heading. All right, tough question, I know. But it boiled down to right triangles around the outside of a non-right triangle, using the sides that you do know, and then using some problem solving at the end. All right, your homework, surprisingly enough, is just like that. It's just like that. You're going to go to this question right here. Ship leaves Old Port. Okay. You're going to do this problem and only this problem and the next problem. These two. Do you remember me saying the lamppost question was important? I did mention that before, not this hour, but back, you have to go back 4 days ago when we had the beginning of the week. We had a question about a lamppost. That was an important one. It's important again. It's going to be important again. Okay, so let's make sure that you spend the time. I'm also not working it all the way out for you yet. I want you to see if you can figure these out. There is a key. Now, this is critical. It's Friday. It feels like we should just have school again tomorrow, but, you know, this week's been really weird, right? If you just decide to not do anything over the weekend, like not practice this, not do any homework, it's going to be like you just extended your 3-day off into 6 days off. You will be useless on Monday, and then the test is Tuesday probably. That would be really bad. So I strongly encourage you over this weekend, practice this stuff. Get it down. It doesn't have to be perfect, but you have to be looked at the key, know what you're doing. Really, this is not the weekend to slack on this stuff, because Monday we review and Tuesday's the test. Unless I can work out 2 review days, I could talk to my colleagues, find out what they're doing. If I can work out a couple of review days, I will, but I can't promise it. So practice this. So I would do these 2 questions. Can you do more? Of course. Let's say you're really bad at this. You do 6 and 11 and you couldn't do either one without checking the key. Then I might try one more. You know, there's another one here. Don't have to do it, but I recommend it. Okay? I mean, I'm saying you could do it. I'm not saying I really recommend everybody does it. I recommend you do 6, check it, see if you did it right. And if you did it right, awesome. Just go to the next one. If you didn't do it right, really look at it closely. If you get 2 in a row wrong, yeah, you probably should do that 3rd one. Okay, so ships down here, and I kind of wish there wasn't ships all over the place on here to draw, but you can just take a blank notability doc if you want to and draw this, but he starts here. He heads directly northwest. Do you get that that means he's going at a 45-degree angle there and 45-degree angle there? Does that make sense so far? Then, once he gets there, don't put an arrow tip on it. Put a compass rose at the end of it. And now you already know that these are 45s and that these are 45s because they transfer over. Because this is a alternate interior to that. You've got to be able to see this stuff transfers over like that. Okay, then we're not done though. From there, he heads north, but 68 degrees west of that, which basically means like that. And he keeps going on that one for 22 kilometers. I should probably label this other side as 16. And where's my final connector? That. So there is my not right triangle, but it's got right triangles all around it. And that 68, it's not 68.22. That would be a tragic mistake. It's 68 and 22 what's? 60ths. Good. In case you forgot that very first day. 68 plus 22 60ths. That's how you get your decimal for that. And that angle is really here, which means, again, you can transfer it over. I haven't even made my compass rose here yet, but I just did. And now you should be able to say, okay, so that angle goes with some angle over here. Yeah, it definitely does. We'll transfer that angle over. All right, you've got a partner. I encourage you to work with him. You got like 8 minutes left. Maybe you can get this one like halfway done together. That's all I got for you for today.